Okay, so ElizaOS recently shipped a V2 update, and one of the key concepts from V2 is this idea of worlds. So worlds is the core architecture in Eliza V2 that enables you to build multi-agent systems. And in this video, I'm going to talk about worlds, introduce you to the architecture, show you how you can build multi-agent systems with worlds, and run through some live demos so you can see how these agents can communicate and collaborate with each other under this world's ecosystem. Before we jump in, just a quick note: if you want to be notified when new tutorials and templates come out, head over to snapperai.io. You can fill out this form to subscribe to the newsletter. Anytime I release new templates, new tutorials, I'll email you with an update. So if you want to know when they come out, head on over here. You can unsubscribe anytime. If you opt in, you'll get an email to your inbox to confirm your subscription. Once you've done that, you'll get all of my updates via email. So just a quick note on that. Now let's jump into the rest of the video. So in a nutshell, worlds can be defined as shared environments where multiple AI agents can coexist, communicate, and collaborate to handle complex tasks together. So think of a world as a digital workspace, like in this example I'll show later, a Discord server, or from a more practical sort of perspective, an office building. That would be how we would define a world. Within each world you then have rooms, so these are specific spaces where conversations and interactions happen. In the Discord example, think of that as a Discord channel. That would be a room. In an office building you might have a floor that would be defined as a room. Each room can host different types of discussions and bring together different combinations of agents. In the real world example, an office building might have a room that's, in this case, would be defined as a floor that is dedicated to marketing. They might have a floor or a room dedicated to finance. Those are how you can define and separate rooms within the world. And finally, entities are the participants in these spaces. So this includes AI agents, human users, and any other interactive elements that can send messages, make decisions, or take actions within the world. So to put it simply, worlds are the overall environment, rooms are the specific spaces within that environment, and entities are everyone and everything that participates in those spaces. So just like in a real office building, the building is the world, the conference rooms and departments are the rooms, and the employees and visitors are the entities. So again, going back to the Discord example, the world is the Discord server. The rooms are each channel within that Discord server, and the entities are the agents and the human users that are interacting within those channels. So you'll see in the future demo that I run through where we'll have a few agents and I will play the role as a customer and ask a question, and we'll see within that room the agents will communicate with me, they'll collaborate with each other based on what prompt I give it from the user input. So what you can see on the screen now is an example of this world's ecosystem, and we're going to use the use case of a real office building for the sake of this demonstration, but I've defined it here in terms of how an ElizaOS world would work. So you can see here we've got 3 separate rooms within the world. The world in this case is the office building. The 3 rooms we've got are general support, technical support, and billing support. So clearly separated functions. Each have their own room. We've then got entities within those rooms. For general support, we've got a support bot and an escalation bot, and customers are the other entities. So customers can go into the general support room, or in a real life example, they can call or message general support, and that's when they would interact with those 2 agents, the support bot and the escalation bot. For technical support, similar setup. We've got tech specialist and code review bot. We've then got developers and customers who might be other entities that engage with those agents in that room. We've then got billing support. So for this one, we've got a billing expert and a payment bot, and then customers are also that other entity within this room. They can all interact with each other. If a customer wants to make a payment, they can call on payment bot to achieve that. If they've got a question about their billing, that's where billing expert might be called on. Then billing expert might be able to collaborate and communicate with payment bot to issue a refund or upgrade a subscription, for example. Within each room there is also room context. So as you can see in the billing support block here on this example on the screen, all agents within each room share the same context, the current conversations, active participants, and the local chat history. So that context is specific to each room, and each agent within that room has access to that context. Then there's the concept of world shared memory, which you can see in the bottom right here. So that is global knowledge that all rooms and all agents across all rooms have access to. So that covers things like customer profiles, cross-room history, company policies, any knowledge bases that agents can refer to from a company or world level, handoff notes, and also resolution patterns. So again, that's accessible to all agents in the world ecosystem. The main plugin that powers this entire ecosystem is the Bootstrap plugin, and that is the out-of-the-box plugin that's available when you create a new ElizaOS project. What I'm going to do now is jump over to the ElizaOS documentation. I just want to give you an overview of the Bootstrap plugin. There's a lot of information in the documentation that shows how the Bootstrap plugin works. So I'll just give you a high-level overview now and show you where to go if you want more information on exactly how the Bootstrap plugin works. Okay, so we're over in the Eliza documentation now. If you want to have a full read through this, which I recommend, you can go to eliza.how to find the full documentation. As you can see here, the Bootstrap plugin is the core message handler and event system for ElizaOS agents. It's very in-depth, the documentation here on this plugin, so what I'll do is I'll just give you a high-level overview of how the message flow works. Okay, so if we jump into the complete developer documentation here, we can see that this is the overview of the Bootstrap plugin. So again, this is the core message handler for ElizaOS agents. It provides the fundamental event handlers, actions, providers, evaluators, and services that enable agents to process messages from any communication platform. So in the example we'll look at shortly, it will be Discord, and then that obviously also allows it to generate responses. So as we can see, this plugin is essential for any ElizaOS agent as it contains the core logic for processing incoming messages, determining whether to respond, generating contextual responses, managing agent actions, evaluating interactions, and maintaining conversation states. So everything from actions to how it should respond to feedback loops and learning and improving over time is all managed in this Bootstrap plugin. As we can see from the architecture overview, a message comes in and hits the event handler. That then triggers the should respond action where the agent, based on its configuration and the message content, will decide whether it should respond or not. If the answer to that is yes, it will then compose state and generate a response. It will then process any actions required, execute any evaluators, and then save the full conversation and event to memory. So that's the workflow that happens when a message is received by an agent using this Bootstrap plugin. So again, it's a really robust plugin that powers the full worlds, rooms, and agent ecosystem. So again, if you want to have a full read through this documentation, I recommend jumping in. That's just a high-level overview of what's included and why it's so important to this world's ecosystem. Okay, so we're back in Cursor now. We've now got a good idea of what worlds are, what rooms are, and what entities are. We understand now how the shared memory is spread across that entire world's environment to power all agents. We've also now got a good idea on what the Bootstrap plugin is and why that's so important to this world's ecosystem. So now looking at this diagram, let's have a look at some of the benefits that this world's ecosystem provides for multi-agent systems. So the benefit is that via that Bootstrap plugin and the other core architecture within ElizaOS, you get access to this architecture out of the box. So you don't have to build all of the custom base layer of how the system works and how all of these agents behave and what actions they have access to and how they communicate and collaborate with each other. That's all available to you out of the box. So you can really cut down a lot of that development time and build multi-agent systems on top of the ElizaOS architecture. You don't have to write custom integration code. There's automatic state synchronization. There's context preservation, platform agnostic operation, and built-in error handling and resilience. So as you can see here, you can have multiple platforms as well. You can have Discord and Telegram, shared memory across all platforms and all agents. There's a web UI platform that you can use as well as another platform where customers or users can interact with agents. There's an API platform, and everything is managed under this worlds ecosystem. So here's an example of how a flow might work with multi-agent collaboration. We'll actually run through this demo in real time in Discord in the next video, but as an example, this is how you'll see this multi-agent system work. So a customer might jump into the general support channel and say, my API is broken and I was charged twice on my account. So all agents within that room would receive the message. So in this case, it's support bot, tech expert, and billing bot. Support bot would then coordinate. So it would update the world memory with that information to say the customer has an API and a billing issue. It would then hand off to the tech expert for the API issue and the billing bot for the billing issue. So in parallel, that will be processed. The tech expert would then respond and say, I'll debug the API issue. At the same time, the billing bot would respond and say, I'll investigate the double charges. So both access that shared context, both update progress in world memory. So each agent has its specific role. And in this case, support would identify that these two agents need to be called on to solve these issues. They would both then jump in and respond. So the resolution coordination then occurs. So both issues are resolved. Support bot would come back to finalize and say the issues are resolved, the API has been fixed, the refund's been processed, and ask if there's anything else. So for the demo, we might not get to the point where we'll see the resolution coordination occur. As it's a demo, we probably won't be able to provide it with the information it needs to actually solve a problem. But for the purpose of the demo, we will be able to see support bot coordinate and collaborate with tech expert and billing bot to solve these issues and communicate with the customer. Okay, so we're in Discord now. This is where I've set up the world's test environment. You can see here, this is the server, so this is the world. On the left-hand side, you can see the channels, so those are the rooms that I've created here. And then on the right-hand side, you can see the entities. So there are 3 agents and then 1 human user, which is me. So we're in the general support 2 room here. I've just created a fresh room for the purposes of the demo, and I'm going to show you how the agents respond and coordinate to a message in live real time. So what I'm going to do here is I'm just going to say my API is broken and I've been charged twice. So like the demo I showed earlier, what we're doing here is we're sending a customer message with 2 distinct problems that are relevant to each agent. So billing bot should be able to pick up that the charge twice keyword means that it's a billing inquiry. Tech experts should see API is broken as a tech problem. So support bot in this case will act as that coordinator. It will first receive the message and then coordinate with billing bot and tech expert to hand off those tasks to each agent. So we'll press enter and see what happens here. After this, I'll also show you the logs so you can see what's happening on the back end as well that makes this work. You can see all agents are now talking. We can see support bot has replied first. It says, I'll coordinate our team to help with both issues. Tech expert will handle your API problem and billing bot will investigate the duplicate charge. Let me get them working on this right away. Tech expert then replies, I'll debug the API issue. Could you provide more details about any error messages or codes you're encountering? Billing bot has then replied as well and said, I'll investigate the charges and process a refund for the duplicate payment. You should see the refund within 3 to 5 business days. Support bot has then replied saying, thank you billing bot for updating on the refund process. Please let me know if there's anything else our team can assist with. So you can see here 3 different agents, 3 specific roles, all coordinating and communicating together to help solve the initial problem that I've mentioned, which is a broken API and a duplicate charge. What I'll now do is I'll respond. Tech expert has asked a question. Could you provide more details about any error messages? So I'll just respond here to see how the flow works once I, as a human entity, reply with more information. I'm just going to make up an error code, so I'll just say API error code 303. And we'll see now this should trigger Tech Expert to jump in. Support bots replied and said, thank you for providing the error code. I'll make sure Tech Expert has this information to assist in resolving your API issue promptly. And then Tech Expert has then replied, thank you for providing the error code. This typically indicates a redirection issue. I'll look into this further and provide you with steps to resolve it shortly. Could you also let me know what endpoint you're using when encountering this error? Support bot has then replied, thank you Tech Expert. I'll ask snapper.sol to provide details about the endpoint they're using for this error so you can continue your investigation efficiently. And you can see they're still coordinating and talking to each other. Tech Expert has acknowledged support bot and said thank you. I'll wait further details from Snapper about this specific endpoint, which will help in resolving their API issue efficiently. Support bot has then replied again and said, can you please provide the specific endpoint you're using? So there's a little bit of repetition here with requesting the endpoint information, but you can see the purpose of this demo, how these agents are collaborating and communicating with each other to help solve these issues. So this is the power of Worlds and multi-agent systems with this new Worlds V2 update. So we'll jump back over to Cursor now and I'll show you some of the backend, the logs and the files that make this possible. But this is just a sort of introduction to multi-agent systems with Worlds and how you can set up specific agents for specific roles and have them work together as a team to solve issues. Okay, we're back in Cursor now. We're going to have a look at the back end to see how this all works. The main files we're going to look at here are index.ts and the 3 character files. So firstly, index.ts, again, that is essentially the ElizaOS runtime. This is where you load and export the character files for your project. You can see here that that's what we've configured here. On line 38, you can see there we've configured the project by identifying the 3 agents that we want to export at runtime: support bot agent, tech expert agent, and billing bot agent. So you can see here the code above also is designed to launch these agents at runtime. That's what makes them come online so that we can then use and interact with these agents, and then the specific character files is what allows them to act and respond and execute tasks in a certain way. So index.ts, again, this is the runtime file. This is where you need to specify the agents that you want to export and run at runtime. We'll now jump over to the character files. So firstly, support bot. Again, this is just a simple character file like the template that you get when you create a new Eliza project. So we haven't had to build anything new here. We've just used that as a template and updated this information so that the support bot acts in a certain way and coordinates and collaborates with the other agents. So we can see here, firstly, plugins. We've assigned 3 plugins to support bot. The Bootstrap plugin, which, as we've mentioned, is that key plugin that's required for agent collaboration and coordination. The Discord plugin, because we've been testing in that Discord environment, that Discord world, we've had to include the Discord plugin here. And then we've got the OpenAI plugin. That is what's used as the LLM model that allows the agents to respond and generate a response. So those are the 3 key plugins here that we've assigned. You can see here then we've got a system prompt, so we've clearly defined what support bot's role is here in the system prompt. You are only a coordinator, you do not solve problems directly, you only coordinate with your team. Your team specialists are tech expert and billing bot. Your only job: respond first to acknowledge the customer, identify which issues they have, say I'll coordinate our team to help with both issues, explicitly assign tech expert to technical issues and billing bot to billing issues, do not offer solutions, do not process refunds, do not fix problems yourself. And then we've got critical at the end: you are only a coordinator, never solve problems directly, always delegate to specialists. So we've got that hierarchy of managers and then specialists and generalists in this setup. In this case, support bot is the coordinator. That's its job, is to respond initially to the request and then hand off to the specialists to handle each issue. We've then got bio, which again has a bit more information, essentially what the system prompt is, but just in a bit more detail and in that first person view. We've then got some topics and some message examples, but as you can see, the system prompt is the key here to defining what support bot's role is. We'll now jump over to tech expert. It again has those three same plugins, so Bootstrap plugin, Discord plugin, and OpenAI plugin. Those are the three plugins that are key here for all agents in this system. The system prompt again is specific here to tech expert, so you are a technical specialist who works under SupportBot's coordination. SupportBot is the team coordinator who speaks first. Your strict rules: never respond to initial customer messages, wait for SupportBot to coordinate first, only respond after SupportBot mentions tech expert or API. When called upon, say, I'll debug the API issue, handle technical API integration issues when directed. You must not respond until SupportBot has coordinated. SupportBot always speaks first, wait for your cue. So again, we've defined tech expert as a specialist who works underneath SupportBot, so it will always wait for SupportBot to respond to the initial customer message. Once it's called on then to work on a specific technical issue, such as the API error, that's when tech expert will respond, as we saw in the demo. And finally, BillingBot, again, very similar to Tech Expert. It's set up as a specialist to respond to billing inquiries. So we can see here that's essentially how the setup works. So we've set up index.ts and 3 character files. So it's pretty basic really in terms of what we've had to build ourselves. It's that Bootstrap plugin that is out of the box with ElizaOS V2 that powers the world's environment and allows us to build these multi-agent systems. So obviously you can get pretty complex systems with many agents and many different rooms within your world, and you can even have multiple worlds as well if you're building a really complex project. This is just an overview or an introduction on what's possible with ElizaOS V2 and the world's environment. Okay, so that's an introduction to worlds, which is one of the key concepts for ElizaOS V2. If you want to be the first to know about new tutorials and templates that I publish regarding ElizaOS V2, and perhaps even some more advanced tutorials on the world's ecosystem, head to snapperai.io. You can just sign up here using this form to subscribe to the newsletter. Anytime there are new tutorials or information that I'm publishing, I'll send an email to that list so you'll be the first to know. So if you are interested, fill out that form, you'll get an email to confirm your subscription, and then once you've done that, you should see any emails come through with new updates. So stay tuned for the next video.